So first of all, what exactly is cross-site scripting? Well, cross-site scripting refers to client-side code injection attacks wherein an attacker can execute a malicious script, also commonly referred to as a malicious payload, into a legitimate website or web application. Now, XSS is amongst the most rampant of web application vulnerabilities and occurs when a web application makes use of something like an unvalidated or unencoded user input within the output that it generates. Now, by leveraging XSS, an attacker does not target a victim directly. Instead, an attacker would be exploiting a vulnerability within a website or something like a web application that the victim would visit, and essentially using the vulnerable website or the web application as a vehicle to deliver a malicious script to the victim's browser. Now, while XSS can be taken advantage of within a VirtualBox script, ActiveX, and Flash, unquestionably the most widely abused is JavaScript. This is mostly because JavaScript is the fundamental to any browsing experience. All the modern sites today have some JavaScript framework running in the background. Now, XSS can be used in a range of ways to cause serious problems. Well, the traditional uses of XSS is the ability for an attacker to steal session cookies, allowing an attacker to probably impersonate a victim, and that just doesn't stop there. So XSS has been used to wreak havoc on social websites, spread malware, website defacements, and phish for credentials, and even used in conjunction with some clever social engineering techniques to escalate to even more damaging attacks. Now, cross-site scripting can be classified into three major categories. So the first is reflected cross-site scripting, the second is stored or persistent cross-site scripting, and the third is DOM-based cross-site scripting. So out here, DOM refers to the document object model that is used while web application building. So let's take a moment to discuss the three types of cross-site scripting. So the first one we're going to be discussing is reflected cross-site scripting. Now, by far the most common type of cross-site scripting that you'll be coming across is probably reflected cross-site scripting. Here, the attacker's payload is a script and has to be part of a request which is sent to the web server and reflected back in such a way that the HTTP response includes the payload from the HTTP request. Now, using a phishing email and other social engineering techniques, the attacker lures in the victim to inadvertently make a request to the server which contains the cross-site scripting payload, and then he ends up executing the script that gets reflected and executed inside his own browser. Now, since reflected cross-site scripting isn't really a persistent kind of attack, the attacker needs to deliver this payload to each victim that he wants to serve. So a medium like a social network is very conveniently used for dissemination of these attacks. So now let's take a step-by-step look at how cross-site scripting actually works. So firstly, the attacker crafts a URL containing a malicious string and sends it to the victim. Now the poor victim is tricked by the attacker into requesting the URL from the website which is running a website response script, and then the website includes the malicious string from the URL in the response. And then in the end, the victim's browser executes the malicious script inside the response, sending the victim's cookies to the attacker's server. Okay, so at first, reflected XSS might seem very harmless because it requires the victim himself to actually send a request containing a malicious string. Now, since nobody would be willingly attacking himself, so there seems to be no way of actually performing the attack. But as it turns out, there are at least two common ways of causing a victim to launch a reflected cross-site attack on himself. So the first way is if the user or targets a specific individual and the attacker can send a malicious URL to the victim, for example using email or for example instant messaging, and then trick him into visiting the site. Secondly, if the user targets a large group of people, the attacker then can publish the link or the malicious URL on his own website or social media, and then he'll just wait for visitors to click on it. So these two methods are similar and both can be very successful with the use of a URL shortening service like one provided by Google. So this masks the malicious string from users who might otherwise identify it. Okay, so that was all about reflected cross-site scripting. Let's move on to stored cross-site scripting now. So the most damaging type of cross-site scripting that is there today is persistent or stored cross-site scripting. In stored cross-site scripting attacks, in stored cross-site scripting attacks, the attacker is injecting a script into the database that is permanently stored on the target application. So a classic example is a malicious script inserted by an attacker in the comment field or on a blog or a forum post. So when a victim navigates to the affected web page now in a browser, the cross-site scripting payload will be served as a part of the web page, just like any legitimate comment would be. Now this means that the victim will be inadvertently ending up executing the malicious script once the page is viewed in the browser. Now let's also take a step-by-step look at how cross-site scripting in the stored version works. So the attacker uses one of the website's form to insert a malicious string into the website's database first. Now the victim unknowingly requests a page from the website, and then the website includes the malicious string from the database in the response and then sends it to the victim. Now the poor victim will be actually executing the malicious script inside the response and sending all the cookies to the attacker's server. So that's basically how stored or persistent cross-site scripting works. Now it's time for the last type of cross-site scripting, which is document object model based cross-site scripting. So DOM based cross-site scripting is an advanced type of cross-site scripting attack. So which is made possible when the web application's client-side script writer uses provided data to the document object model. So basically it means that data is subsequently read from the document object model by the web application and outputted to the browser. So if the data is incorrectly handled in this place, an attacker can very well inject a payload which will be stored as a part of the document object model and then executed when the data is read back from the DOM. Now let's see how that actually happens. So first the attacker crafts a URL containing a malicious string and sends it to the victim. Now this victim is again tricked by the attacker into actually requesting the URL from the website. This is like the primary step in actually performing cross-site scripting. Now the third step is that the website receives the request but does not include the malicious string in the response. Here's the catch of DOM-based cross-site scripting. So now the victim's browser executes the legitimate script inside the response, causing the malicious script to be inserted into the page. That is basically into the inner HTML attributes. And the final step is then the victim's browser then executes the malicious script inserted into the page and then just sends the victim the cookies to the attacker's server. Now, if you guys must have realized, in the previous examples of persistent and reflected cross-site scripting, the server inserts the malicious script into the page, which is then sent as a response to the victim. Now when the victim's browser receives the response, it assumes that the malicious script is to be a part of the page's legitimate content and then automatically executes it during page load as with any other script would be. But in a DOM-based attack, there is no malicious script inserted as a part of the page. The only scripts that are being actually automatically executed during the page load is legitimate part of the page. So that's the scary part. So the problem is that this legitimate script directly makes user input in order to add HTML to the page. So the malicious string is inserted into the page using inner HTML. So it's passed as HTML. So mostly people who are actually servicing or surveying any server for cross-site scripting attacks, they will not be actually checking the client side. So it's a very subtle difference, but it's very important. So in traditional cross-site scripting, the malicious JavaScript is actually executed when the page is loaded as a part of the HTML server. And in DOM-based cross-site scripting, the malicious JavaScript is executed at some point after the page has already been loaded, because the page's legitimate JavaScript treating user input is using it in an unsafe way. So now that we have actually discussed all the three types of cross-site scripting that is widely available today, now let's see what can actually happen if you were actually a victim of cross-site scripting. So let's see what can happen if you actually were a victim of cross-site scripting. So the consequences of what an attacker can do with the ability to execute JavaScript on a web page may not immediately stand out to you guys, but especially since browsers like Chrome run JavaScript in a very tightly controlled environment these days, and JavaScript has very limited access to users' operating systems and user files. But when considering that JavaScript has the access to the following that we're going to discuss, we can only see how creative JavaScript attackers can get. So firstly, with malicious JavaScript has access to all the same objects that the rest of the web page has. So this includes a thing called cookies. Now cookies are often used to store session tokens, and if an attacker can obtain a user session cookie, they can impersonate that user anywhere on the internet. Secondly, JavaScript can read and make arbitrary modifications to the browser's document object model. So your page will just be incorporated with all sorts of scripts and viruses without you even knowing from the server side. Now, JavaScript can be used with the XML HTTP request to send HTTP requests with arbitrary content to arbitrary destinations. And the most scary part is that JavaScript in modern browsers can leverage HTML5 APIs, such as accessing a user's geolocation, webcam, microphone, and whatnot, and even specific files from the user's file system. Now, while most of these APIs require the users to opt in, cross-site scripting in conjunction with some very clever social engineering can bring an attacker a very long way. Now, the above in combination with social engineering, as I just said, allows an attacker to pull off advanced attacks including cookie theft, key logging, phishing, and identity theft too. Now, critically, cross-site scripting vulnerabilities provide the perfect ground for attackers to escalate attacks to more serious ones. So now that we understand what cross-site scripting attacks are and how damaging they can be to your application, let's dive into the best known practices that are actually followed to prevent them in the first place. So the first mechanism that is used is called escaping. So escaping data means that taking data an application has received and ensuring that it's secure before actually rendering it for the end user. Now, by escaping user input, key characters in the data received by a web page will be prevented from being interpreted in any malicious sort of way. Now, in essence, you're censoring the data your web page receives in a way that will disallow characters, especially those brackets that begin the HTML attributes, like in HTML and IMG. So these will be stopped from being rendered, which would otherwise cause harm to your application and users and database. But if your page doesn't allow users to add their own code to the page, a good rule of thumb is normally to escape any and all HTML, URL, and JavaScript entities. However, if you are running a forum and you do allow users to add rich text to your content, you have a few choices. So firstly, you will need to carefully choose which HTML entities you will escape and which you won't, or by replacement format for raw HTML such as Markdown, which will in turn allow you to continue escaping all the sorts of HTML characters. Now, the second method that is normally used is called validating input. So validating input is the process of ensuring an application is rendering the correct data and preventing malicious data from doing harm to the site, the database, and the users. So while whitelisting and input validation are more commonly associated with stuff like SQL injection, they can also be used as an additional method of prevention for cross-site scripting attacks. So input validation is especially helpful and good at preventing cross-site scripting in forms, as it prevents a user from adding special characters into the fields instead of refusing the request completely. But input validation is not the primary method of prevention for vulnerabilities, such as cross-site scripting and even SQL injection for that example, but instead they help to reduce the effects should an attacker actually discover such a vulnerability in your system. Now, the third way to prevent cross-site scripting attack is to sanitize user input. So sanitizing data is a strong defense, but should not be used alone to battle cross-site scripting attacks. It's totally possible that you find the need to use all three methods of prevention in working towards a more secure application. Now, as you guys might notice, that sanitizing user inputs is especially helpful on sites that allow HTML markup to ensure data received can do no harm to users, as well as your database by scrubbing the data clean of potentially harmful markup and changing the unacceptable user input into an acceptable format. Okay guys, so that was all the theory about cross-site scripting. It's time for the demo right now. So for the demonstration now, I'm going to be showing you guys the three types of cross-site scripting that we have discussed throughout the course of this session. So not only will this be rather interesting to see how cross-site scripting works on a vulnerable web application, but it will also give us a better understanding of cross-site scripting in itself. Now, to perform cross-site scripting is a very big crime, so we really can't target any random website or web application for that matter. So keeping that thing in mind, I have chosen the Broken Web Application project. So this is brought to us by OWASP, which stands for Open Source Web Application Security Project. Now, the Broken Web Application Project, or BWAP, is a broken web application that is intentionally vulnerable, and it incorporates a majority of the known bugs that are out there. And it is widely used by security enthusiasts, students, and practicing ethical hackers to mostly practice and nurture their skills in the right direction. Okay, so to get started, first of all, we need to download a few files and get things ready. So first of all, we'll download the broken web application project, and I'll be leaving the download link in the description just in case you guys want to practice in your own free time. Secondly, we'll need to download a VirtualBox. Now, after we have both the files ready and we have it installed and we have our broken web application installed in the virtual machine, we are good to go. Now, I've already done all that boring job and actually installed the broken web application. As you guys can see, I'm already running the OWASP broken web application on my virtual machine, and this is the OWASP virtual machine. So as you guys can see, it's based off Linux, and if we go ifconfig, it'll give us the IP address that it's running on. So as you guys can see, it's running on 192.168.146.4. So if we just head over there, yeah, I've already opened that up, we get a portal. So for this particular demonstration, I'm going to be using the broken web application project and also WebGoat. So first of all, let's head over to the broken web application project. So we'll be greeted with a login screen out here, and the credentials for this is B and bug, as you guys can see. So just go and enter login after you've entered the credentials. Okay, so you all will be welcome with a place where you can choose your bug, and you can also choose the amount of security that you want to practice with. So since this is a very simple demonstration, I'm going to set the security to low, and the first thing that we're going to test is actually reflected cross-site scripting. So reflected cross-site scripting mostly has things to do with the GET request when we are actually coding on the back end. So let's see. So first of all, we go ahead and choose reflected cross-site scripting for the GET method, and we go and press hack. Now we'll be presented with a form. Now form is a very good way of actually showing reflected cross-site scripting, because normally when an attacker will be trying to attack you, he'll be trying to send you a form or any way you can actually input something into his server. So interestingly, if we go and just input nothing into these two fields and just go, we'll see the URL change out here. So firstly, you guys see that the fields are very clearly visible, and these are the two fields, and that means that it's an unencoded input. So this is a very rich place to actually practice your web vulnerability and penetration testing skills. So if I were a hacker, I would try and run a script out here. So if I were to go script, and I've already practiced a few out here, as you guys can see. So if we go script alert, this is an example of reflected XSS. Yeah, and if we go and just end the script out here, this is going to actually render the JavaScript input as a part of the page, and we are going to get an output because of this. So that's how reflected cross-site script is actually working. So as you guys can see, what am I saying? As you guys can see, the web application has actually rendered our JavaScript, and now we can see that reflected cross-site scripting is actually working out here. So now you guys must have realized that in a practical scenario, this form must be sent to the victim and must be tricked into filling the form for the attack to be successful. Also, in more practical scenarios where sites are also having forms, they're going to be putting filters to the content of the input parameters such that you cannot run JavaScript in them, and you cannot also input any unencoded inputs into them. So that was all about reflected cross-site scripting. So now let's move on to stored cross-site scripting, which is the most dangerous form of cross-site scripting. Okay, so as I had discussed, the comment sections are normally the best place for actual stored cross-site scripting. So as you guys can see out here, we already have a few comments that I had added for practicing. Now in stored cross-site scripting, the attacker is normally attacking the data that is stored. So basically we are going to inject the script into the database, into the server. So if the script has some malicious intent, and it can do a multitude of things if it has a malicious intent, we'll not get into that. So for that reason, let's first add a normal comment out here. So let's say if this was a blog, I'd say good job there, like I'd said, or something like, hey man, nice work. And if you go and press submit, okay, it's showing this is an example of persistent cross-site scripting because I had already inserted a malicious script. So this is that script out here, the second input. But just for demonstration purposes, let's go ahead and input it again. So we can also input raw data, that is unencoded input, in the form of a script. So let's go alert. And let's just print hello world. So if we go and press submit, so it first runs that other cross-site script, and then it'll say that this page isn't working. So this is also a very good example. Now we have two scripts actually running on this page. So the first one is actually, this is an example of cross-site scripting, persistent. So that was the second one. And then comes the hello world. So that's actually two scripts running back to back. So anybody, if I were to actually come back to this site any other day and these comments existed, it would just get automatically executed from the database because we are referring to it. Okay, so time for DOM-based cross-site scripting, and I was using this application for the first time yesterday, and I realized that there is actually no way that we can actually test DOM-based cross-site scripting here. So to actually test DOM-based cross-site scripting, we are going to be using this thing called WebGoat. Now the login credentials to WebGoat is guest for the username and guest for the password. I had already logged in, so it didn't ask me. So now if you go out here and go under cross-site scripting in XSS, you will also see that there is no options available for actually DOM-based cross-site scripting. This is because it's under AJAX security, or AJAX if you might pronounce it that way. So this is under AJAX security because if you guys remember, we had just discussed that DOM-based cross-site scripting is a client-side cross-site scripting. So things like a normal script would normally be checked on the server side. But when we are talking on client side, we are talking about languages like HTML, AJAX, etc. So you can put your scripts in HTML form. So suppose we were to go, so let's input a script first. So suppose we were to go script hello world. Now if we go and submit the solution, nothing actually happens because we are actually putting in encoded inputs out there. It's the DOM that is unencoded. Now if we were to actually go in and input in a language that the client side actually understands, for example HTML, so we'd immediately get a result. So first of all, it's going to actually manipulate the inner HTML attributes of the site. So if we go image and we put a source, now let's not give the source anything, and on alert, on an error, we're going to run some simple JavaScript. So alert, and we can say this is an example of DOM-based XSS. Now as soon as I end the image tag, this is going to get run because the client side is always rendering the client side page. So watch this. Sorry, I think I mistyped somewhere. Okay, let's go again. So image. Okay, let's use something I've already used. And you can see that it says hacked. And out here, we've not even pressed submit solution. So out here, you can see that as soon as we completed it, it's again saying hacked. So that means as soon as you complete the query or the client-side HTML language, so that will completely trigger the cross-site payload. Image tag, this is going to get run because the client side is always rendering the client side page. So watch this. Sorry, I think I mistyped somewhere. Okay, let's go again. So image. Okay, let's use something I've already used. And you can see that it says hacked. And out here, we've not even pressed submit solution. So out here, you can see that as soon as we completed it, it's again saying hacked. So that means as soon as you complete the query or the client side HTML language, so that will completely trigger the cross-site